Easy calculations. Okay, so we want to be able to get exact answers whenever we can on all these trigonometric functions. So of course, when you have your 30, 60, 90, your 45, 45, 90, you know all the sides and the triangles, you can give me exact answers. So to do these, we're going to sketch our angle, like the very first section, so good review, thinking about our quiz coming up. I'm going to sketch the angle, I'm going to draw the angle, make my angle, make sure it lands in the correct quadrant. That's nothing exciting. We're going to determine our reference angle. This is key. Now, your reference angle is between the terminal side, remember that is the one that rotates around the circle, and the x-axis. Now, today, all your reference angles are going to be something on these special right triangles, 30, 45, or 60. Clearly, that is not always the case that it turns out to be, 30, 45, 60. We have other tools that we will get to in another chapter on dealing with that, just for the record. Okay, you're gonna make your right angle, your right triangle with the x-axis, not the y, the x, okay? You're gonna label your sides, your 30, 60, 90, your 45, 45, 90 down there. You're gonna label your sides appropriately, and then do your SOHCAHTOA total whenever they're asking you whatever trig function we need. So, let's do it. Okay, one other thing too. Why are these out of order? Here we go. Where is my, okay, there we go. Good grief. Okay, start drawing out 135 degrees. So good review. This is from the first section. Now I'm going to get dramatic and label the first one, but we don't have to label every single one. Remember our 0 degrees, 90, our 180, our 270, and of course we all know by now when you get to that full circle, 360. Now just to review, of course, when you draw your angle, the vertex is on the origin, initial side on the positive x-axis, throwing the vocab back at you. Terminal side is the one that rotates around the circle. Now, positive angles rotate up or counterclockwise. So 135 degrees, I'm at 90. 135 is going to be over here in quadrant 2. And like I said, I'm going to dramatically label the first one. I don't know if we have to get this carried away every single time. So I'm going to just label from 0 around, I covered 135. Now, we need to get a right triangle out of this so we can use our SOHCAHTOA. Remember, you always make the right angle with the x-axis. X-axis, not y, x. Now, most important, I need this little bitty reference angle, we call it. Remember we said it's always going to be 30, 60, or 45. So you're going to do a little mental math here. From 135 to 180, how much more do you need? 45. So we are clearly on our 45, 45, 90 right triangle. So triangles down there if you need the sides. Sides, of course, 1, 1, square root of 2 for hypotenuse. Now, before I crank out, I need cosine, adjacent, hypotenuse, piece of cake. I got it. But wait. You're in quadrant 2. One of the sides on the triangle needs a negative due to where you're located. Because if you go from the origin, we went left and up. Which one of these sides needs a negative? The left or the up? Next question. Will your hypotenuse ever need a negative? No, because when you do Pythagorean theorem, square the side, positive, square the side, positive, your hypotenuse will always be positive. Okay, now I just need cosine, adjacent, -1, hypotenuse, square root of 2, and story of our lives, we have to rationalize it out. Final answer, negative square root of 2 over 2. This is what we're doing today. So you're drawing the angle, making your right triangle, watching due to location the negatives. That's usually the only thing anybody ever misses. And then your SOHCAHTOA. All right, 300. Now again, I don't think we have to get crazy and do as much labeling as I did on the first one. That was mostly for review. 300 degrees is going to land you in which quadrant? 4, because we're at 90, 180, 270, 300's over here. So from here around, we covered 300. we're going to make our right triangle with the x-axis. And most importantly, what's your reference angle? 30, 60, or 45? 60. To make a full circle, you need 60 more degrees. So, it's super tiny if you can see them over there. Hopefully remember from yesterday. Across, this would be the 30. Across the 30 is 1, the smallest side. Across the 60, root 3. Hypotenuse 2. Now, due to the location again, one of the sides needs a negative. So you can figure that out. From the origin, you're going right and down. Which one needs the negative? The down one. Final answer, I need the fraction, the ratio of the sides that represent tangent. So TOA, I need opposite over adjacent. I'm not going to leave it with the 1. I'm just going to put negative root 3. Got it. Okay, sine of 210. So of course, we don't have to get crazy with all our labeling. You probably already know 210 is going to land in which quadrant? 3. So 90, 180. Let's not get a protractor out and measure. I'm going to ballpark that. So from here around, 210. And I don't care if you put that labeling on. I just like to put it on so I can kind of see in relation to my circle where I'm at. X-axis, our right angle with the x-axis. Most importantly, what's your reference angle? 30, 60, or 45? 30. 30. From 180 to 210, we covered 30 more degrees. So 30 is your reference angle. Okay, label your sides. Opposite the 31. Opposite the 60 would be your square root 3. Hypotenuse 2. Do any of the sides need negatives? Which ones? Both, yeah, because you're going left and down. And final ratio I need is sine. So I need opposite, hypotenuse. Got it. All right, any questions on that one? Elliot?
Would the hypotenuse ever need a negative?
Nope, because when you do your Pythagorean theorem and square these, they're going to kick out positive. So
and also if it's a ratio, if one of them, the ratio has to include at least one sign, so the negatives.
Right.
Yeah, I see.
You got it. Okay, so more of the same, more of the same. I just got super fancy. Super fancy, not really fancy, kind of fancy. And I gave you some radians. So, I mean, big deal. I would really just have one extra step. It's going to be easier to probably work in degree. Am I out of order? Yeah. Get it together here. Okay, so only thing that changes here, I thought let's get off of sine, cos, and tan. You can see we got some secant and cotan, big whoop, reciprocals. But I gave you kind of bigger angles. So kind of boo to that. You've seen my drawing skills. We all can comment on how poor those are. I don't want to have to go around the circle plus some more. That's just a little bit obnoxious. So my pro tip, of course, I would use a coterminal. There's a good vocab word for us. I would use a coterminal angle. This is a throwback to the first section. How do you find coterminal angles? You add or subtract 360. Save yourself a little bit of trauma, right? So I see that 495, that gets a hard boo. I don't want to go a full circle plus some more. So I'm going to make my life easy and use my coterminal. I'm going to take 360 off. You'll land at the same spot. What's 495 minus 360? 135. I hope nobody used their calculator for that. Okay. All right, mark out your 135. Here we go. Now it's just like the others. Vertex on the origin, initial side. So of course I'm at 90. 135 is going to be over here shy of 180. I like to label, that's my 135. I'm going to make my right angle with the x-axis. And most important, what's your reference angle? 30, 60, or 45? 45. 45 more to get to 180. Our sides, of course, 1, 1, root 2. And always, before I crank out what sides I need for cotan, which side needs a negative? Yeah, because you're going left and up, so this guy needs a negative. Now, we need the sides for cotan. Remember, cotan's the reciprocal of tan. So instead of opposite over adjacent, I'm just going to flip it. You need adjacent over opposite. So I'm like, all right, I got it. Adjacent -1, opposite 1. That was a whole lot of work for a -1 answer if you ask me, but here it is. Got it. Okay, one more that's over course 360. I didn't want to go around the full circle plus more, so I'm going to deduct off 360 and use a coterminal. What is 405 minus 360? 45. I like that. That's nice and easy. Right in quadrant 1. Clearly, we're going to be on a 45, 45, 90. Shocking news there. To get my angles drawn. Of course, 45 is between 0 and 90. So we're on our 45, 45, 90. Now you're in quadrant 1, so every side's positive. You need the sides for secant, which is the reciprocal of cosine. So I need hypotenuse over adjacent. So hypotenuse root 2, adjacent 1. Just going to go root 2. Got it. Any questions on those guys? Okay, I'm scared. All right. It's one of those days, I guess. So this, only thing that changes, I gave them to you in radians. Big deal. Probably easier to convert them into degrees and mark it out from that point. Can you mark them out in radians and work in radians? Sure, but it's a little more time consuming with the fraction work. Plus, I just like to review, because you have your quiz coming up, to convert radians to degrees, what do you multiply by? 180 over pi, yeah. So just a little practice of the first section. Of course, the pi's cancel. 3 goes into 180 60 times. So obviously, I gotta look. I don't know what 16 times 60 is off the top of my head. I can calculate that. What do you got for that? What's 16 times 60? Yeah. I don't know about you. I don't want to draw 960, do you? So you're going to take off not one full circle. I would probably take off 2. What's 2 full circles? 720. So I'd subtract 720 off. And we're going to end up with what? $240. I like 240. I can roll with 240. That seems easier. And again, I don't need to see all of that work. You can just do that in your calculators, obviously. I'm just writing it out for your notes. I don't know 16 times 60 off the top of my head. Okay, so 240 is going to land you in which quadrant? 3. So we're going to be past 180 over here. We're, as always, making our right angle with the x-axis. Most important question of the day, what is your reference angle here? 60. 180 plus 60 more gets you to the 240. All right, opposite the 31, opposite the 60 root 3, hypotenuse 2. Do any of the sides need a negative? Which ones? Yeah, both of them. And final answer, we need sine, so I need opposite hypotenuse. So negative root 3 over 2. Got it. All right. Now, B is 1. Actually, I think I'm just going to roll with the negative pi over 4. Because that's so common, hopefully we just know it by now. Pi over 4 is how many degrees?
45.
45. Because pi over 2 is 90. Half of 90, half of a half, a fourth, 45. So I just am like, well, I'm not going to convert it. I just know it. I hope you do too. Don't let the negative scare you. The negative, remember, just affects which direction you rotate. So since it's negative 45, you're rotating clockwise or down. So you're going to be here, of course, in quadrant 4. Now, when I ask you for the reference angle, am I putting 45 or negative 45? Just 45. The negative just affects your direction. I care about that clearly we're on the 45, 45, 90. And of course, you need secant, the reciprocal of cosine. So hypotenuse over adjacent. So that one was easy. I hope you'll see pi over 4 a lot. You just don't know. Can you convert it and do the 180 over pi? Sure, I don't care. This one, can you convert that one in your head? 150. 60 goes into 180 3 times, so 150. If you gotta do all the converting, do it. Now, I do in some years have kids that for whatever reason, they just hate negative angles. They hate rotating clockwise, they just hate it. I don't understand why, it's not that offensive to me. You could add 360 to it and use a positive coterminal and you'll land in the same spot. Personally, negative 150 doesn't wig me out too bad, I'm just gonna go with it. Now remember, it just means you're rotating clockwise or down. So I'm at negative 90, negative 150 is gonna be over here in quadrant 3. Remember, the negative just affects your direction. Most important question of the day, what's the reference angle? 30. For the 500th time, opposite the 30, opposite the 60, hypotenuse. And of course we need cotan, so I need adjacent over opposite. So adjacent, opposite, got it. So any questions on that guy? Let's see if the slides are in order. Not I'm scared. Is that the next thing?
Yep.
Without me grabbing. All right, so obviously the next thing we need to talk about is what about your 90 degrees, your 180 degrees, your 270, your 360 if you're on the axes. And this is where we're going to use your yellow sheet today too. So this is the next thing I'm going to show you how to evaluate. They are called quadrantal angles. That's their little fancy name. And that's your 90, 180, 270, 360. They're on the axes. So you cannot make a triangle out of them. So we have to do this a different route. So to evaluate it, we're going to use the unit circle. That means, yes, I have to draw a circle. Prepare yourselves for that. Remember, unit circle, centered at the origin, radius 1. So up 1, right 1, down 1, left 1. The x coordinate represents, of course, cosine. The y coordinate gives you sine. Now, to me, that's easy to memorize, okay? Because it's alphabetical. The first coordinate's cos, second sine. Now, what about all the other functions? Tangent, cotan, secant, cosecant. What about the other ones? Well, yellow sheet, secant is 1 over cosine. Cosecant is 1 over sine. So I can use those identities at the top. Tangent does relate to these. Look on your yellow sheet in the second group under quotient identities. Tangent is what? Sine over cosine. So I can divide them out. Now, just for the love of math, okay, I can't help myself. You don't have to write this. I just want to, I'm not going to prove every identity on that sheet to you, but I just want to prove to you that this works. Sine, of course, is our opposite over hypotenuse. Cosine's your adjacent over hypotenuse. You guys know when you divide fractions, we multiply by the reciprocal. Opposite over adjacent, tangent. So it's another way you can define or come up with tangent. I'm not going to do all of them, but you can get the gist, okay? So I'm going to have to use that identity to get tangent, the reciprocals to get secant, cosecant, etc. Okay, good. I think we're in order. Evaluate the trig functions of the following quadrantal angles. So the good news is there's not a lot of work to these because they're going to be the points. So remember, you are on the unit circle. So if I was to mark out the unit circle, here we go. This is a positive one. Could be better, could be worse. Okay, we're just going to accept it. Now, 180 degrees, we all know where 180 is. There's my 0, my 90, my ding, 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 180. So clearly I'm looking at this 180 over here. So I want this ordered pair. I want this point. Well, I had to go left 1, and we're on the axes, so 0. So even though it doesn't seem like you have a lot of information, you have a lot of information. Because the first coordinate's cosine, second one is sine. Always alphabetical. That's a cheat way to memorize. So I'm like, yeah, I got it. Sine of 180, 0. I'm done. And normally when I do these, I don't get that elaborate and draw the circle and mark everything on every single one. I just slap down the point and write the answer, okay? So that's what I'm gonna do on the next few. We're just gonna make our lives easy. We all know where 270 is. If I were to draw the circle, which I'm not, 270 is which point? Top, bottom, left, or right? Bottom. So I just mark the point. I think in my ordered pair, well, you would go down 1, so 0, -1. And which one of those coordinates represents cosine? First one, 0. We're done.
Now I just got it.
So you get these are easy, but a little tricky at first. Okay, 360. Which point is that? Top, bottom, left, or right? Right. 0 degrees, 360, full circle. Ordered pair, we went right 1. I just didn't draw the circle. Now, you need tangent. You have cos and sine. So this is where you have to use your yellow sheet and use that identity. Tangent is sine divided by cosine. And of course, 0 over, well, anything. We've done a whole lot of work for some pretty easy answers, right? But, I mean, easy. We just got to know how to do them. All right, let's do some other ones like secant, cosecant, some of the other ones. So same thing, just first figure out your point, top, bottom, left, right. So 90 degrees, which point is that? Top, bottom, left, or right? Top. Ordered pair. So this ordered pair, you went up 1, so you're 0, 1. Now, secant. You have, remember, cos and sine. So your yellow sheet, reciprocal identities, secant is also equivalent to 1 over cosine. Cosine 0. Final answer, undefined. 0 under the line is undefined. So that's why we started with the calculator problems yesterday when you had to do like cotan. I did it 1 over tan. I know there's other ways to type them in the calculator. Secant, 1 over cos. That's why we started using those. All right, I'm not going to convert that. We know what negative pi over 2 is, right? Negative pi over 2 is really how many degrees? 90, negative 90. So which point? Top, bottom, left, or right? Bottom. Ordered pair, 0, -1. Now you need cosecant. You have to remember cos and sine. So our identities, we know cosecant's 1 over sine. Final answer. -1. 1 over -1. Got it. So that's how you do the quadrantals. You can do them off the points and using a little bit of identity. Okay. Any questions on those? I'm scared to click next and see if we're in order. Yeah, help us. Is this my order? Is that right? Okay, good. All right, the last thing I have for you, which is going to bleed into tomorrow's stuff too. So of course, sometimes it's not as obvious when we start solving equations and different things where you're finding the angles. I'm not giving you the angles. You're finding the angles, where to actually draw the triangle, which quadrant. So that's what this is all about. So it says it helps to determine which quadrant. So first, let's get the quadrants up here. All right, for dramatic emphasis, I'm going to label the quadrants. I know you know where 1, 2, 3, 4 are. Notice I kind of put the labels kind of at the bottoms because I'm going to write some stuff in here, so leave yourself a little bit of room. Okay, so 4 quadrants. Notice in that saying, the saying is what is actually beneficial to us. 4 words in the saying, 4 quadrants. Each word matches to a quadrant, okay? Now, here's the deal too. You're like, what is this really telling us? Of course, I gotta head to it. This is telling you which quadrants your functions are positive in. So I'm gonna put where the functions are positive. So, the 4 words in the saying match up to the 4 quadrants on the graph. So the A, of course, for all goes to quadrant 1. That means every single function is positive in 1. Sine's positive, cos positive, tan, secant, cosecant, I don't know which one I forgot. All 6 of them are positive in 1. Okay, S. S stands for sine. Second word, second quadrant. So sine is positive in 2. Now, of course, what goes along with sine, whatever's true for sine, is also true for its little partner in crime, cosecant. But I always try to work in the main 3 trig functions, sine, cos, tan, and then, of course, you can reciprocal to get the others. All right, T. What do you think the T stands for? Tangent. Third word, third quadrant. Tan is positive in 3. And, of course, its little buddy, cotan. Kind of like Jackson and Kale in quadrant 3 together, their little buddies are positive there. Okay. Couldn't help myself. And then the C. Which trig function do you think that stands for? Cosine. So cos is positive in 4, gets partner in crime, secant. So to me, that's kind of a lot of a dramatic picture to draw out when I'm trying to come up with the angle in which quadrant. So here's my little shorty version. Okay, when I'm just working on the homework and I just want it in front of us and I'm not getting crazy, I'm just like, all right, I got it. All students take calculus. So I'm just like, everything's positive, sine, tan, cos. So that's my little shortcut version because that's kind of obnoxious to have to write all of that out if you ask me. So all we're going to do for today with this is just practice. I'm going to give you some info figuring out which quadrant you would be in. Tomorrow I'm going to add to it and we'll actually get the triangles and all that sort of stuff going. So all we have to do is determine the quadrant in which theta lies. All right, okay, I'm on it. So I'm going to draw my kind of my little shorty one. So my all students take calculus. Now the first thing I don't like about the given info, I don't like that they gave you secant and cotan. We like to work in the main 3, sine, cos, tan. So whatever is true for secant is true for cosine. So most importantly, greater than 0. Greater than 0. Cosine's positive. So right now, I can kind of pick out 2 quadrants cos is positive in. So it could be 1. Everything's positive in 1. Cos is positive in 4. So I'm down to 1 and 4. Clearly, it's going to be either of those. It's not both of them. We're going to narrow it down. Well, whatever's true for cotan is true for tan. And I'm like, oh, that's a problem. If tangent's less than 0, tangent's negative, can you be in 1?
No.
No. So we'd have to draw it in quadrant 4. So it's kind of a process of elimination. So we're just practicing this today. We're going to add some more to it tomorrow. All right. All students take So I'm using my little shorty version. I like that they gave you tan to start with, greater than 0, so positive. So right now, what are your 2 potential quadrants? 1 and 3, the all and the T. So of course, we got to eliminate. I don't like that it's cosecant, but that's whatever's true for cosecant is true for sine. I'm like, less than 0. What are you getting rid of? So we would have to draw it in 3. And like I said, we're going to add more to this tomorrow. We're going to start finding angles and drawing triangles. We're just getting it set up for you today. All right, so lots